SIMATIC PCS 7 version 9. And this is about how to get digitalization to the field level. And we're going to be talking with the portfolio marketing manager for automation and engineering. Please give him a warm round of applause. Here is Manuel Keldnich.
For the kind introduction.
Look at that. See that applause here, Manuel? You got your
great.
fan base.
Just a few people.
You brought your fan base with you. Great.
You start to getting me nervous, right? And yeah, thank you very much for the warm welcome. And I guess when you've been at the Siemens booth and experiencing what we're showcasing here, from MindSphere over the Digital Enterprise Courtyard. So now it's a little bit more about talking about digitalization down to the field level. Means the area within your plant, in the process industries, where you really have your field devices, your pumps, and your installed base of flow meters, pressure measuring, etc. So I would like to start talking just a couple of minutes about the challenges in the process industry, because one can imagine that you only earn money with your plant in the time it is in operations. You can imagine having an oil rig, for example, in the Norwegian Sea. It's producing an amount of value of 10 to 15 million euros each day. And if you imagine this oil rig is maybe due to maintenance or a breakdown, not able to produce for 1 day or 2 days, this is quite a significant amount of money that you will lose each and every day or each hour already. So this is one of the challenges. Another one is investment protection. When you're engineering a plant in the process industries, you know that you will operate this plant for 30 or even 40 years later on. And you already have to consider this right in the beginning in the engineering, when you're defining the size of your plant, the capabilities that he has to fulfill, and also the cabinets for the controllers, the remote I/Os have to be defined, have to be climatized. And this is a physical installation that you cannot easily change from time to time. And yeah, this is the challenges to really have in mind what will happen during the next couple of years. Because when you have this runtime of 30 or 40 years, you have to imagine you have to exchange equipment, you have to modernize this plant, you have to, maybe your production is running really well, you have to extend the plant, but you have an environment that you cannot change. So this kind of room for new perspectives comes into the game. When you think about how can I live with the installed base, with this installation, and make it more productive without needing more space for that. So if you have been at the Siemens courtyard already today, digitalization is the answer on nearly each and everything, so also for us in this case. And how can we bring digitalization down to the field level, down to the flow meters, to the equipments that you have installed? And we use the industrial Ethernet communication standard PROFINET to really create future-proof solutions. PROFINET enables us to bring digitalization down to the field level, to the installed base within your plant. And it is an open standard, so it can be used by all manufacturers in this industry. And what's really important on PROFINET is that you have communication in real time. You can exchange signals and data immediately. That's important when you want to know what's the status of my plant, my installation, how it is working in operations. Another important topic when we're talking about modernization or plant extensions is I need network structures that are scalable. Means I can easily extend them without needing more space, or I can change the architecture of the installation. So this is really the basis for future-proof solutions in the process industry. And with room for new perspectives in the new version of SIMATIC PCS 7, we have several innovations, 2 big hardware innovations and also software innovations for sure, because we're talking about a new version. And one of the hardware innovations is our remote I/O, SIMATIC ET200 SPHA, which is based on PROFINET. And the second one is our compact field unit, which is the basis for a completely new and decentralized approach in plant modernization projects. I'm going to talk a little bit about some use cases of these 2 hardware innovations and just give you a short overview on the software innovations. But I would like to talk a little bit more in use cases than just in features. One topic, as I already mentioned, is having enough space or having limited space and trying to go bigger in the production with that. And that's the reason why we were reducing the width of the existing technology by nearly 50%. That means in the end you can put more remote I/Os into a cabinet. Or, that's not on this slide, we can also apply this remote I/O, the SIMATIC ET200 SPHA, directly in the field because it has a conformal coating. That means you can place it in an environment from -40 to +70 degrees. If you imagine, for example, an installation in the chemical industry, a big petrochemical plant, it's really important to place the topics also outside the standard cabinet and place it down to X zone 2. Due to the reduced space and the usage of PROFINET, we were able to increase the number of modules. That's just try to, a little bit. It's really small, the green one. You have a so-called head-end station here combined with a redundant PROFINET interface and up to 65 modules behind. In the past, we were only able to place 12 modules in behind. So you can imagine that with an installed base, you can realize a lot more signals within a standard cabinet. And now in a standard cabinet, which has a width of 80 centimeters, is 2 meters high, we can now operate more than 900 I/O. So this is quite a lot of signals. Due to integrated terminal blocks, we also save space because we do not need the MTAs, which is basically something that is consolidating and distributing the cables from the control cabinet down to the field devices. We save a lot of space. Another use case is the so-called online change, because we can exchange a module, for example, which has an error, directly in run. And we do not need to shut down the plant or to stop operating of our plant. So in the end, we just put it out, insert a new one without needing any equipment or screws, for example, replace it, and the plant is up and running. This is really important. And for us, that means that we avoid downtime and the risk of errors is significantly lower than it was before. The third use case is the standardization of control cabinets. We use uniform terminal blocks and have a fixed wiring, and that allows us to standardize the setup of a control cabinet. And the benefit for the customers that he buys it has a lot of flexibility, can lower the costs and effort for the installation, for the commissioning, but also for the documentation, and is what's really important for the factory acceptance test, which has to be done before you start operating your plant. In the end, the commissioning is much, much faster. So the benefits are obvious. The temperature range is important. The number of connections that is significantly increased, and that you have cost and space savings. I think this is clear right now. Another topic is the SIMATIC compact field unit, the second hardware innovation highlight. With this nice little box, which has a size like this, we can go and place it directly within the field, connect it via PROFINET, redundant, and then go with Profibus to the connected field devices, like a flow meter in this example. And we can mount it outside in the field, also in the temperature range of -40 to +70 degrees in X zone 2. And what's really nice about this is that we drastically reduce the amount of cables that you need that go into the field. We had already some pilot projects with customers, and we were able to reduce the effort of cabling by 60 to 70%. And if you imagine the value that copper cables have, this is quite a lot of money that our customers can save. And due to this decentralized approach, we are much more flexible when expanding the plant, for example. The effort for all the planning and the documentation is much lower because we deliver one standardized box, which does everything that is needed, including the documentation, and you do not have to do the documentation for each and every wiring and channel that you have assigned to the devices. And talking about devices, the device integration is another very important use case, because you can imagine Saturday night, the maintenance staff is informed that one flow meter is not working correct anymore. So you have to call this guy, tell him, okay, you have to exchange this device at night. So no one of us would like to exchange somewhere outside in the field devices at night in the weekend. In the past, such an exchange took 1 to 2 hours maybe. So this is quite a lot of time. And if we are talking about a process that is really value adding, it means you have a downtime, and this costs you a lot of money in the end. So how can we improve device integration with our new compact field unit? We just replace the device, take it out, insert the new one, which is maybe more efficient, maybe from another supplier. Maybe you use Siemens now because the competitor's flow meter has broken. And you insert it, make the wiring via Profibus PR to the compact field unit, and the compact field unit does an automatic addressing of this field device and gives the information to your control system, which is SIMATIC PCS 7. And you just have to check a click box, and then the installation is done. Your plant is operating. It generates value for you. And we made the proof that it takes you just around about 1 minute, so it's really fast. It's as simple as connecting a printer to a computer. You inserted it, you have an initialization, and then you confirm that this is the right printer that you connected. We call this plug and produce. In the end, I think I have to speed up a little bit. Time is running. We have more flexibility, cost savings, time savings. Yeah, that's it basically. Software highlights. Because we're talking about a controlled system, which means we do not only have hardware, we also have a lot of software components for engineering of the plant, for operations of the plant. One of them is our process device manager, which is a perfect supplement to the monitoring and the integration of field devices, which is linked, for example, to our compact field unit and makes the projecting much faster, and is also supporting the PROFINET standard. Another one is our SIMATIC batch. This is a solution that is really important for industries like food and beverage or pharmaceutical industries, where you have the creation of recipes and the engineering of the equipment modeling. And in the past, it was possible to do this in one step only. Means when there is another party, another supplier, or another system for the recipe creation involved in the process, you had a problem. Now, this can be done in 2 different steps, so you have much more flexibility in this regard. Regarding our maintenance station, we improved the data integration from the field level to the operating system and to the enterprise asset management, for example, an SAP system, to make sure that data is always consistent. And another highlight of our software is the management console that enables you to have anytime the right status of your installed hardware and software available, and can directly check the status. So this results in less workloads for the operators, better documentation, real-time overview on your plant status. So, yeah. At a glance, why are we talking about for room for new perspectives? Because we have more flexibility with the SIMATIC PCS 7 version 9.0. We have a future-proof solution based on PROFINET. We have massive cost savings and less costs. And in the end, what's most important, the profitability of your installed plant is much bigger. And if you want to challenge the things that I'm telling you right now on nice slides, you can come to our courtyard, the PA courtyard, which is directly behind the digital enterprise. And me and my colleagues will be very glad to answer your questions and prove what I just told you in the last couple of minutes. Thank you very much, and have a nice day here.
Thank you also.